It all started 17 years ago when I was a first-year student. It was 1998 Christmas, actually, and I was a little bit bored. It was break time in the learning, and I wanted to have some fun. Right? What do people usually do when they want to have some fun? Well, I started playing with permutations. Don't you do that? Oh. So for those of you who don't, let me say that a permutation is simply a sequence of tossed numbers. Nothing more than that. And what I wanted to do is to rearrange those numbers, for example, like that, and see the effects of this rearrangement. And that's how I came to the idea of a certain way of transforming it. It was a function which I saw to have some unusual properties. These properties can be defined as one way. The transformation was one way, which means that you can get the new transformation, the yellow one, from the old one, white one. But if you have the yellow one, you cannot see from what white one it came. So you cannot invert this transformation. You cannot invert this function. I analyzed this for about 2 years because it's, as we will later find out, an interesting property. And I still couldn't find any error in my thinking. So I thought somebody must have thought about this transformation before and written about it. So I started consulting scientists and asking them, where can I read more about this transformation? Well, unfortunately, they said to me that they haven't heard about it. After hearing a few such answers, it became more and more clear to me that I discovered something new. I continued my research, and after 5 years of analyzing that transformation, I wrapped it up in a paper and submitted it to a scientific conference where I was accepted, and that's where I published my function. It was in 2004. The conference was FSE in India, and after that I published the function on a few conferences here in Poland. And during the time, I was more and more becoming aware of the fact that my function was also related to a certain mathematical problem, a general problem called P versus NP. This problem asks, this question asks, whether there exist problems which are hard to solve, but easy to verify. Well, this might seem like a trivial question, but in fact it isn't, and mathematicians have not been able to answer it for years. And even more, Clay Mathematics Institute listed this problem as one of 7 most important mathematical problems not yet solved. To stimulate research on each of those problems, it founded $1 million prize for solving any of them. And that gave me even more excitement about it. Now, one of the ways to solve the P versus NP problem is to find a one-way function. Why is that? For a one-way function, as we saw on the sequences of numbers before, deriving x from f of x is hard. So inverting the function is hard, but evaluating the value of the function is easy. So solving the problem is hard, verifying is easy. Now, do one-way functions exist? yes and no. There are a few ones which are believed to be one-way, like encryption algorithms, hash functions, or factoring of large numbers. But unfortunately, for none of them, there exists a proof of one-wayness. So formally, one-way functions do not exist. Hopefully, the first one will be VMPC. This is the name of my function, and formally, it is still believed to be one-way function, but I hope it will change. Now, let me say a few words in short how the function works. Well, this is how it works. Something wrong? Well, if the +1 is red, then the result is 3. No? Okay, so maybe let me explain in a few more details. If you combine two ingredients, you sometimes can get more than just the sum of them. Let's look at one ingredient. It's digit 1. Well, is it interesting? Mathematically, 2 + 1 is 3. Nothing particularly interesting. 3 times 1 still remains 3. Not very interesting. Well, what interesting can you do with 1? Maybe have 1 beer. Let's look at another ingredient. The permutation composition. Don't be scared, it's a simple thing. F is a permutation, which is here, and to do this, you have to just jump 3 times from index to value, so 1, 2, 2, 6, 6, 3, and 3 is the first number of this thing. And then you repeat it for these numbers and you get 7 new numbers, and that's the composition. But still, it is nothing very interesting. You can easily invert this transformation. But how about mixing these two ingredients, the 1 and the permutation composition? We would get something like this. The composition and the red +1. And we proceed analogously with a slight modification. 1, 2, 2, 6, 6, it was 3, but now we add 1 to 6, so 6 + 1 is 7, and we see what lies under 7, it is 4. And that's the only difference between VMPC and between the regular permutation composition. We repeat this for each number, and we get variably modified permutation composition, which is the abbreviation of the name of the function. Now let me illustrate the effects of this transformation. Imagine that x is water, and for a regular function, for example, function called freeze, the value of the function is ice. If you wanted to invert this function, you would apply a function heat, and you would get x back. So you invert the function easily with heating. Now, if you get the +1, which is an additional ingredient, here it is cement, and you mix water with cement, then the value of the function will be concrete. And now, our task is to invert the function, so retrieve water from concrete. Well, good luck. And that's basically the strength of VMPC. More specifically, how hard is it to invert the function? For a 30-element permutation, so we saw 7 numbers, and if we had 30 of them, we could accomplish it with a computer. If we had 100 elements of the permutation, then it would be a task for all computers in the world, 1 billion, billion, billion operations. But for n equaling 250, it would be a cosmic number of 1 and 77 zeros. That's the number of operations required to invert the function. And imagine that each atom of Earth, of which we have about 10 to 50, is a super fast computer. Then it would still take 20 billion years, 1 billion year, I exaggerated a bit. It would still take only 1 billion years, sorry, not that much, to invert the function. Oh, of course, you can extend the size of the permutation more, and the complexity of inverting it grows rapidly. Now my task is to prove it. What I'm saying is as it appears to be, but formally it has not yet been proved. However, a draft version of the proof of this claim is already complete, and I'm working on writing it and hopefully publishing that, and hopefully again waiting for other people to accept this correct. So formally it's just an assumption. And an unexpected side effect of my research was a board game which I designed and produced. And why is it interesting? Because the board game is directly illustration of the process of inverting the function. So technically, the game Permuto is the VMPC function, and despite the function may seem something complicated, but actually it's not. The game is very simple. The game exists in physical form. And now it's been 17 years that I've been working on this project, and now let me share a few thoughts what I have learned generally about research process and investigating new things. First of all, think out of the box, beyond schemes. That's what I applied when combining my two unrelated elements, the +1 and the permutation composition. Think beyond schemes. Following schemes is a helpful thing day by day. It can keep you from making mistakes, it gives you safety. But if you are interested in discovering something new, then you would rather go out. You would rather take a different route out of the schemes, and only then you are beginning to have a chance to discover something new. Be naive. You get an idea and you think, oh, it cannot be interesting because if it was, someone must have written about it. Well, if you think like that, you will never discover anything new. So believe in your idea. If you figure out something new, believe that it can be something actually new and actually not published anywhere. And during analyzing this new thing, be prepared to take wrong ways. You discovered something, so you went off the schemes. You have no schemes how to work. And to analyze a problem, you have to wander around. You have to lose way and take many wrong ways before you actually take the right one and find the solution to the problem. So be prepared that it will happen, and be persistent. Be persistent, not to give up, not to lose your naivety after taking another wrong way. Persistence is a very important thing from what I've learned that can allow you to actually finish the work. And this is an illustration of my process of analyzing the function. These are all the wrong ways that I took. To be honest, about 70%, so majority of the time of my research was a wasted time. It was the time for reaching these red dots, where I thought, oh, this is a good idea for looking at the function. I followed it, and bang, I cannot go further. I have to go back, and only after a lot of time I found the way to proceed to reach the solution, my draft proof of one-wayness of VMPC. So be prepared for that and don't lose patience. Now, when you go deep into a problem, any problem, you may discover some interesting things. By going deep, I mean analyze something for, say, a week, a month, a year. You can discover that time can solve complex problems. A problem which at the first glance seems very complicated and discouraging, well, if you give it a shot and devote some time, you can get some conclusion. Then you are richer by that conclusion, and you get to another conclusion. These conclusions fuel one another, and after one month, for example, you will be surprised how far you came. So, like they say, time heals wounds. I would also say that time solves complex problems. Be prepared that inspiration is an important factor. It is a soft factor, you cannot call it, but it's necessary to give you new ideas which route to take on that tree. And inspiration is fussy. I have no recipe how to call it, and you just have to be prepared and respect it. You can also have some unexpected side effects, like, for example, my Permuto game. How the game was born was maybe funny, I don't know, but I was so much soaked in with the function that I was beginning to see my numbers, those digits, everywhere. I was once walking down the beach, and I was looking at the stones under my feet, right? And of course, what I saw numbers of VMPC function in them. Yeah, and then I actually realized that I don't even need numbers to represent the function. All I need is those stones, and that's actually true. And those stones are the tiles with symbols in the Permuto game, and you actually can represent the function with symbols with no compromise. It's direct illustration, mathematical illustration. So things completely unrelated, a board game and a mathematical function. Don't be discouraged by criticism. Now, if you present a new idea anywhere, there will always be a group of critics. Be prepared for that. It may be conservative people, it may be unfulfilled people, for example, who will attack everyone who proposes any new idea. Well, of course, there is good criticism. Criticism allows to verify ideas. But there is no general rule. Be prepared that criticism will be always there, and if it is, then it doesn't mean that your idea is wrong, not at all. It only means that people heard about your idea, nothing more. The general rule is that novelty raises skepticism. I notice even something more, which may be a bit controversial, but I think that the more vicious the criticism is, the more it may confirm the value of your research. That's the way it is, I think. I believe that people subconsciously feel the value of a potential discovery, and if they feel that the value is big, then some people may be a bit angry that it's somebody else's idea, and they may attack you. Let me share a few actual comments which I heard about VMPC in 2002 when I was researching this function. It was before publication. Well, these are genuine quotes. I give 10 to 1 odds that it's a hoax. You're a bloody liar. It's bloody well damn sure to be untrue. And this was from the guy who was a regular attacker. And when he said bloody, considered the amount of blood in this quote, I really think that he was thinking about something like that about me. Another one is my favorite. The function, when printed out on a soft enough paper, can be used to wipe my arse. Yeah, these are genuine quotes, and now we are laughing. I'm also laughing with you, but imagine I was asking people for advice, and I heard something like that, and I was sorry. But if I had given up, I wouldn't now be here. So just be prepared to hear comments like that. Oh, that was his idea. Now, finally, let me ask you, what do you think is the difference? I mean, what do you think? Think for yourself, is the difference between madness and genius? You might think that these are completely different things, opposite things. Someone mad, someone genius. Come on, what they can have in common? Well, think for a second and One word. I think the only difference is success. They do the same thing, they think in a similar way, and a genius, it's simply a madman who succeeded. Now, as a final thought, let me share someone else's one, but this one I experienced myself as very true. When something cannot be done, it takes someone who doesn't know that, and he will do it. Okay, so that's what I learned. Thank you.